We born ready.
Born ready.
Han tænkte sig at lave en introduktion. Han tænkte sig at lave en introduktion.
Okay. Góðan daginn og velkomin á þennan fyrirlestur í þessari fyrirlestra síðustu 2 daga, síðasti fyrirlesturinn. Það Stafræn Veröld og öryggi í netþjónum sem hefur verið kallaður. Það var hérna daginn í sitthvoru lagi, sitthvoru fyrirlesturinn, en nú búið að taka hann saman í svona aðeins meiri, taka þess að 2 saman í 1. Þannig að það verður svona skiptur og stóri í því. Og hérna, Larssen hann byrjar og það Stafræn Veröld sem hann ætlar að byrja og svo kemur Stafræn með öryggi í netþjónum. Þannig að við skulum bara byrja þetta bara, gjör svo.
I guess that meant I had to start. My Icelandic is a bit rusty, so we'll continue in English. Yeah, my name is Larssen. I think he said that already, but I'm not sure. I'm a Technology and Digitalization Director in ABB in Copenhagen, in Denmark. So the next half hour we'll talk about digitalization, and then we will switch to cybersecurity, and Pierre will take care of that. A few words about ABB in Denmark. We have around a little bit less than 500 colleagues. We're located in 5 different offices, except for Aalborg, that's up here in Denmark. Then the rest of the office is more or less on the east-west line, with main office in Scotland, where Per and I reside. Then we have one in Odense, in Fyn, one in Valencia, and one in Esbjerg. So it's almost on an east-west. We made almost 2.5 billion in 16. And we have a lot of focus on safety and customer experience. That's what we work on. If we look what areas we work in, then we can split it in different ways. The first one is products. It's the biggest one. It's almost 60% of what we're doing. Then systems, and systems is software and products together, is around 1/3, or a fourth, 25%. And then service and software is 18%. If we see what kind of industry we work in, then utilities is almost 1/3, industry a little bit more than 1/3, and transportation infrastructure a little bit less. And then in the global footprint is almost the same size in Asia, Middle East, and Africa is a little bit more than 1/3, and also South America is 1/3 as well, and Europe is roughly 1/3 of what we do. We do have representatives in more than 100 countries, and in some countries like Iceland, for example, we represented by, in this case, Johan Running, if we don't have an office ourselves. But we do have offices in a little bit more than 100 countries. And we are out, actually this one is not correct anymore, we are 145 now, because we acquired a company recently. So we have a lot of colleagues. We have to be very careful we don't send to all when you send a mail. Then you get a hell of a lot of out of office back. So this one is a different way of looking at it. We do a lot of what we call building automation, intelligent installations in buildings, combining light, ventilation, heating, and transport infrastructure, electrical buses, electrical cars, vessels. We have something called an acid pod. That's actually on the cruise ship that just parked out here. We have the way the propulsion is done is using something called acid pod, which is basically an electrical way of doing it. So they can almost have the same speed sideways as forwards. And we have something called shore to ship, so they don't pollute everything when they're in the harbor. And we do a lot for trains and tunnels. Industry is a big thing. We represented almost every industry. We have products and services and solutions for that. And we have a multi-entity supply. renewables, traditional power generation, transportation, solar, anything that has anything to do with power or automation, ABB is there. So, digitalization. I call it what, when, and how, because digitalization is something that's really hot topic right now. But basically, we have been working with digitalization in the last 30 years, because automation is digitalization. Or you can't automate anything if it's not digital. It has to be connected. So there's a few numbers. I'll start with some numbers. And this one is the first one, and I'll give you 5 seconds to guess what it is. Number of mobile devices contra number of toothbrushes. So actually, there's more people who own a mobile device than toothbrushes. So that's really digitalization. I mean, I'm one of them myself, because I have a cell phone, I have an iPad, I have my smartwatch. So a lot of people have a lot of devices. I don't have 3 toothbrushes. Actually, now you can actually combine the two. So you can get a toothbrush that has digitalization built in. So it actually has measurement in the toothbrush, and then it sends the data to the cloud, so you can actually get trained in how you should brush your teeth correctly. So we'll bring that next time we can. There's some other numbers that might be you know already, but the biggest taxi company in the world doesn't have a single cab. It's pure business, so it's just digitalization and Uber. I don't think you have it here. We don't have it in Copenhagen anymore. We had it for a few months. And then the biggest hotel chains doesn't have a single room, but they have the digital that needed in order to have that success they have. And the same with media, Facebook. They don't produce content. They might remove content, but they never produce anything. And the biggest retailer in the world doesn't have a single stock anywhere. Pure software, pure digitalization. So it's quite amazing that all these companies is digitalization in a nutshell. So digitalization has a lot to do to technology, but it's more business models. Business models you build up using digitalization. Here's another number where the McKinsey Institute has looked into what they think would be the technologies that will have the most impact by 2025. And then the Internet of Things, which basically is whatever can be connected, that has the biggest impact. That could be anything. Sometimes we call it industrial Internet of Things if it's connected to industry. Then the next one that's really big is the mobile internet, that you get connection nowhere while you are. And the third one is really interesting one, automation of knowledge work. How do we use artificial intelligence in the future? Especially in the automation business, in Denmark at least, where we know it best. Then there's a couple of guys that have the same age as Per and I, and most likely within the next 10-15 years we will do something else. And we have a lot in this population in Denmark that started with automation in the early 80s, where we started everything, and we started our career at that time. So we need some way that we could put all this knowledge into something else in the future. And that will be artificial intelligence, and that will really boom the next couple of years. Then it's down there. There's a lot of technologies. Personally, I think the 3D printing will have a big impact. I think that will do a revolution to normal warehouses with components, because instead of putting all the components on stock, we just print them when needed. It's doable. The technology is there, but it's not that used yet. There's one number 6. The autonomous cars or near autonomous vehicles. I think that will do a little bit more revolution than this one. The bad thing is that we're very scared about this kind of technology. I don't know if you read that I think it was Tesla, they already have this system, and it passed across when it was red light, and then they stopped the project. And daily there's several thousand people getting killed in the traffic because people fall asleep, they get a heart attack, they don't watch what they're doing. But immediately when it's something with technology, people are very scared that no, it won't work. I don't know how these guys fly, because I would not fly back in a manual driven plane today. I would really prefer to have an autopilot, and I hope they have. Okay. Next slide. This one is from a survey they did in Denmark last year. It's a union called IDA, which all the engineers in Denmark, most of them are part of this. So they asked all these, what do you think about digitalization in the future? And the potential was 46 billion Danish, which is a hell of a lot of money. I wouldn't mind get 10% of this as orders. And then 1/3 said most likely they would outflag production, or at least part of the production, if they didn't digitalize. And this one, they really want to keep the R&D and production. We have a number of companies that actually outflagged the production, but they kept the R&D in Denmark. And now they're actually pulling back the production again, because separating is not the best way of doing it. Then when they ask why they should digitalize, then they would lower the production cost. And if you lower the production cost, it doesn't matter if the factory is in Mumbai or in Maribo, as we said, which is a small town in Denmark. It doesn't matter. If it's fully automated, it could be anywhere. And it lower the scrap and higher quality, all parameters that makes it cheaper to create your products. And the flexibility. A lot of companies talk about the batch size of one, so it's very personalized. That you get, you need a lot of flexibility in your production in the future. You can't do these big batches and then just put it on stock and wait until somebody buys it. And again, to avoid the outflagging. And then they asked for the barriers. And some of these didn't see the opportunities at all. So this one is a typical example. These guys are so busy by pulling the truck, so they don't even think about if the truck is optimal to do it. The other one was there's a lack of time. So they say we're so busy that we can't do digitalization because we're too busy. This one is a really big one in Denmark. It's very, very hard to get the right resources with the right competences in doing digitalization. This one is even worse, because if the management doesn't know it, then they won't start anything. So that's why I put this one in. It could be the engineers we can't get, or it could be the managers we already have. And then the last one was the lack of capital, so they don't think they have enough money to invest in order to digitalize, even if they know it's a good idea to do it. So that's kind of the survey, and I think it's pretty applicable to what we hear as well in the industry. So back to the digitalization and the ABB ability. Basically, ability is our new umbrella name for whatever we do in the digitalization business. So we have a lot of products, existing products that we will start rebrand as ABB Ability. For example, the biggest system we have for automation is called A1XA. Now it's called ABB Ability A1XA because it's a digital product. It's been on the market for 15 years now. So it's digitalization in a nutshell. If we look at some of the technologies that's actually driving all this digitalization, then we have this one is very interesting. Virtual reality, which basically you put on glasses and you get into a complete new universe. We have a set of that in Copenhagen, so if you pass by our office, be welcome to give us a call and try it out. Another one that might be even more interesting is what they call augmented reality, which basically you see the true stuff, and then you get additional information. For example, on my glasses, if you had a head up here, then you'll get additional. So when I move around in my factory or whatever, I'll get additional information that's relevant for where I am. That's called augmented reality. Then there's a lot of different technologies here. One is inexpensive computing. I have an example here. This one is a full-blown PC. I can turn it on. I can figure out how to do it. Here it is. Now it's actually active. So if you go into your mobile phone now, you'll see there's a new hotspot called ABB Editor, which basically is a full-fledged computer. It has Bluetooth, it has Wi-Fi. The computation power is like a PC 2 years ago, and it costs $10. And the computer itself is actually this tiny little guy. And then it's on a print because otherwise it couldn't get connected to it. And Pierre will tell you in half an hour why you shouldn't connect to this one. Because if you connect to it, we will suck out all your information from your cell phone because it's doable. But that's part of the cybersecurity. So I won't tell you why you shouldn't do it. But it's a tiny little guy. This one is a little bit more expensive at 10. But the chip itself is only $10. Then a really hot topic is basically what we said already, the machine learning, which is basically artificial intelligence. How can we do intelligence so that it's actually helping us understand our process and stuff? Big data, of course, is really important to get with cloud computing. I mentioned Facebook before. I read an article that every single second there's posted data into Facebook and Instagram that will take 7 years to read for one person. So it's amazing how much data we produce, and we don't use it for many things. For example, on YouTube, I don't know how many trillion of bytes that are stored of videos of stupid cats, and it's basically active for around 5 to 10 days, and then it's getting onto what we call the data graveyard. It's still there, but it's never touched. Nobody looks at these stupid cats. I understand why, but and it's just for the cats. And then there's a hell of a lot of data that's pushed into someone, and that's why they build all these data centers all over the place to keep all the old videos with old cats. So it's quite amazing that we just continuously push, and it's like a curve like this, so it's exponential. So we need to figure out how we can use all this data. Perhaps not the videos with the cats, but some of the other data. This one is fairly interesting as well. It's well known for Bitcoins, this new currency that doesn't exist, but it still exists. And blockchain is a way to do a transfer between A and B without having a middleman, typical for a bank transfer. So that I can send money to you if I wanted, and I didn't have to go to my bank to do it. Unfortunately, it's used by the wrong guys, so it's a little bit way of washing your, what they call laundering your money. But the technology behind it is very interesting and can be used to a lot of different stuff in the future. Time-sensitive networking is another very, very interesting topic. We work a lot on this, which means that you can start using wireless devices as if it was connected directly, as we know now. Okay, let's move on. So I normally use this, sometimes I use this picture and say, can you figure out where we do digitalization on this picture? I don't know if you know this, that's a Dutch guy doing cartoons. So you have these where around 2,000 people, and then you have to find them one on color. This one is like this. So where do you think we have digitalization here? Very simple question, because it's all over. So it's transportation, it's trains, it's cities, it's geothermal, energy, it's wind turbines, offshore, anything, all can be digitalized, and it is already to a huge extent. So it's all over the place. This one is a different way of looking at how the different type of industries are adapting the digitalization. So the y-axis is the level of digitalization, and this one is over time. And this S-curve is a well-known one for what we call adaptations of new technology, or adaptations of new something. And down here it's almost not adopted, and up here it's running almost 100% of this one. For example, the IT business. I mean, IT business doesn't make sense if you don't digitalize it. Another one is media. I mean, it's hard to get a DVD anymore. Some people don't even spell it correctly. You stream everything. When did you last buy a CD? Some of you guys that young perhaps don't even know what a CD is. It was some old-fashioned that took over from what we call the cassette, which was tape, that took over from vinyl players. So everything is streamed now. Finance is another point. I don't know when I was in a bank last time. I never went to the bank. I just used my mobile bank. It's called Denmark. And I gave an example when we did this yesterday. That I was in New Zealand in February, and I never touched a note or a coin. I don't know how the money looks like. And to be frank, I don't know how Icelandic money looks like. Because I haven't seen anything, I didn't need anything, because I just have my credit card. So that's digitalized as well. Then if we retail is a little bit, you start ramping up and buying on the net, but you still have physical stores, at least we have in Denmark. And then it go down and down and down, and then agriculture is kind of the lowest level of adoption of these new. You can get all this technology, it's available. You can get auto-guided tractors and machinery. But it's not that well adapted yet. Or the dark The dark one here is the industry we work in from an ABB perspective. I already mentioned that we have actually been in this business quite a while. So we have a lot of devices out there connected already, delivered from us. I say 70, it's closer to 100 million enabled connected devices. We have a lot of systems, typical control systems, PLCs, to control all the devices, a typical automation system. A solution is a complete solution for something, more than 6,000, and we already have 50 cloud-based services and analysis package and stuff. What we do now is that we try to streamline everything so that it will go into this, what we call the ability, which consists, again, we have all these devices and sensors. That's basically where it starts. This one could be one of these sensors or something similar to this. And then it's turned into automation systems that basically collect all the data and control everything from here, going to plant enterprise solution for a complete plant worldwide or locally. And then the last one is in the cloud, where we start exchanging data with others, perhaps. And we get data from other people. So it's more the big data stuff is up here on the top. Again, we already have more than 180 solutions that's actually doing this, branded differently, but then it will be in the ABB brand, the Ability brand in the future. And that will be both from utilities, industry, and transportation. It will be the same for all of them. A few examples, what we mean by digitalization. This one is what we call the intelligent building. So instead of having a normal on-off switch to turn off the light, you will have a sensor that actually detects when you push it. It will send a message to someone, and then it will start the lamp. So you will have a little device it's almost like this one, is even tinier than this, on the wall, and you will have a similar one on the lamp. You will have several of all these all over the place. And the way you program it is that you say, okay, when I push this one, the message should go to that one. And if this one is detecting that somebody is moving, then I should put on all the light. And then it can get very intelligent, so you can, what they call the follow me light. So when I check in the morning, then they know it's me, and I know where my office is. So it will turn on all the light, so I can get into my office without turning on. I know you guys don't care about energy, I know that, because the power doesn't cost anything up here, but we do. So that's a lot of initiatives to lower the power consumption. And this one is one way of doing it. And that's called KNX. It's a standard, so it's actually not only ABB delivered, so it can connect. So you could have, I can't say it, but there might be a competitor name that would create something similar that we can connect to because it's a standard. That's one example. It's integrate the heating, it integrate the ventilation, light, solar panels if you have solar panels, geothermal if you have above what called the yeah, I think so. Okay. This one is the first robot we created with 2 arms, and it's the first robot that doesn't have to be in a cave, so it can actually be next to us. Per could be a robot here, and it will be okay if we could work together, because it wouldn't slap you very hard. He might do it, but the robot wouldn't. So it's what we call a collaborative robot. You don't program it, but you train it. So basically what you do is that you take it by the hand, and then you do what it has to do. And on YouTube, last week, we had one of these. It's called Yumi, like you and me, but spelled differently. Then we teach the robot how to conduct Veröld's opera, and they did that in Venice last week. So instead of having a normal conductor, they actually use a Yumi robot. It looked pretty cool. And it's an example that you don't program. In old days, you program the robot and say, okay, please move the arm from XYZ to XYZ2, and then move it again. So it was kind of a programming. Now you just teach it, and then it will do it. Next version will be that it will figure out itself with vision systems and so on. When we start to adapt the artificial intelligence, but that will be next time we have. Then this one is very interesting, and that a lot of people is very high interest in this. To do maintenance on your motors, instead of doing RAMs where you do measurement on the motors for vibration, you can put in a new wireless device that we just put on the market. Looks like this. Very inexpensive, and you just attach it to the motor, and then it will start doing analysis on the motor. Vibration, temperature, current, a lot of stuff, and you just put it on, and then you have an app on your phone, so when you get close to it, you will see the health of the motor, and it will actually send the data to the cloud, so you can do more analysis in the cloud as well. And it's very inexpensive, 1,500 Danish. It lasts for between 3 and 5 years. So that just put on the market. I think there's a few installations up here already for test installations. Really interesting product. And again, this is digitalization in a nutshell. You can do it today with the traditional lot, but then you have to do wiring and put up a PLC and get all this stuff together and send it to somewhere and do something. Now everything is built into this guy. And it's a battery. It's sealed. It's IP67, I think it is. So you just put it up and then you're up and running. Yeah, if you want to have a look. That's not much to look at. So that's another example of digitalization, how you can benefit from the new technology, simple and cheap. Here it is what it can do. So all the bearings conditions, the cooling condition, rotor condition, and air gap condition, it will figure out from the analysis based on the vibration, and you get the energy consumption, vibration rate, temperature, and operating hours straight out of the box. This is how it works. So you put the sensor, you use your smartphone or gateway. The gateway is not released yet, but it will soon. So that you can have one gateway covering a lot of motors, so you don't have to walk around with your cell phone. Right now you have to do this, I think it can store data for 2 weeks or something. And then you will walk around and then it will send it to the cloud. And then you have what we call user web portal, where you get a lot more analysis capabilities than you get on the cell phone. And it can push the data to the to another cloud system or to an automation system if you want to use the information for maintenance. If you have an asset management system, for example, then you can push the data to that. A few examples on utilities. We have software and products for microgrids, for maintenance workflow management, trading system for the energy market. Again, might not be that interesting up here since it's costs nothing. But in some industries, it's actually a lot of money you can save by doing the production at the right time where the energy is cheap. It could be digital substation, distributed energy, and this one is an asset system, so actually figure out how to treat your assets best in the best way. A lot of different applications, a lot of different products for the utilities. For transport infrastructure, we have all the EV charging and all the services around that. So when you get close to zero, more power on your car, you know that okay, if you go in that direction, it will be 10 kilometers, but there's already 2 in queue, so it will take 1 hour before you get charged, or you get a warning before. That's a lot of software behind it, not only the charging. It's more like on this one, the coordination. And the energy management for these really big data centers, they consume hell of a lot of power. So doing the management for that, from the energy perspective, is fairly important as well. The data center is very easy to move a production from one center to another one, but they can actually close down a data center very fast because they just move the. So let's say we have a data center here in Iceland and we have another one in I don't know, Singapore. And then they figure out that the power the next 3 hours will be much cheaper in Singapore than Iceland. Very hypothetical, but then they just move all the stuff to Singapore, run there for 3 hours, close down this one, and then they switch back. And that's doable because the production system is digital. They just move the data. Another one is the navigation for optimization for fleets and remote monitoring of the electrical systems of ships. So that they don't monitor it on the ship itself, but they have a 24/7 operational center somewhere that keep track of all the ships. Sorry. Then for industry, this one is an example how you can create a complete simulation of a robot system, for example, or conveyor and robots. And you can run it in real time and figure out how to do it. And then when everything is up and running correct, you can deploy it in the physical environment, and you save a lot of money because you don't have to do all the testing on the physical equipment. So it's a way to get this up and running much farther. We already talked about the connected robots. We do have a lot of software for execution systems, for MES systems to run your production. The control systems, we have a lot of these, more than 20,000 installation worldwide, where you can control and you can do it remotely as well. We have the cybersecurity, Pierre will talk more about this one, and we have the energy assessment as well. A lot of different products, a lot of different software packages for the industry. A few words where we're moving. So this one is a typical example of what we call a control loop today. That's basically how everybody works. You do some kind of sense, you measure something, you do some analysis on it and say, okay, what do I have to do? I have to do something, and that's my act. And then this circle will continue on and on and on. And this one is very common in whatever control you do today. Very deterministic, you measure, and you do analysis, and you act. If you go to autonomous, Stafræn, you'll get a different circle on top of it, because you still have your facts in here, but then you have to perceive, understand, and solve instead of. That's a little bit different, and it requires that you have some skills like a human brain, for example, to do it. That's why the artificial intelligence in the future will help doing this. Then a lot of people say, no, it will never get to there. A machine cannot think as a brain can do. I don't think so. I think it will be very close that it can. Actually, already now there's some artificial intelligence that has the ability to program itself. So we'll see a lot of that in the future. So if you look at the, especially in Germany, there's a lot of focus on what they call the Industry 4.0, which basically is the fourth industrial revolution, as they call it. They're referring to the first one was the mechanical, when they invented the steam machine, so they can get energy anywhere they want. The next one, when they could create electricity. The third one was when we started using software, and this one is where Per and I started in the early 80s. Doing the software business, then digitalization, which started a little bit in 15 or 16 or 17, depending. And then the next, we don't know when, but then we will start using the artificial intelligence much, much more. And to be honest, it's fairly hard to predict how that will be. So it will be interesting when we get here in 10 years. Again, it might be a robot doing some presentation here. We don't know. This one is a different way of seeing it. So you have the human, and the human has the intuition and creativity, and to some extent it has expertise, because we have a lot of knowledge from all the years we've been in the business. And computation, you would say, okay, yeah, I can do some computation in my head, but can I do it fast and precise? Not compared to artificial, because the expertise is that you can store a hell of a lot of data and it will know forever that it's there. They don't have a bad memory, it will always keep them, and it has a lot of computation power. What it doesn't have, at least not today, is that it doesn't have intuition and creativity. And if you combine the two, then you will get some augmented in here. That's half human, and we will get help from the artificial world. And then if we look into a really bad scenario, then this one will take over everything, and we will be in the minority, while the robot will rule the world. Hopefully it will not happen, but you never know. Very few words, because I'm running out of time, I guess. When we talk about ability, we use these terms. Cloud computing is fairly well known, which basically where you have some data, whatever, and it puts the data to the cloud. Fairly well known. What open up, I think, is what they call the fog computing, which basically is the same as a cloud, just called fog because then it's closer to the ground. It means that you have all the data on-premise, but you use the same technology as you use in cloud. And then the really interesting one is what we call intercloud, which basically is that we have our ability where we have some data, but we don't force our customers to push all the data to our cloud. It could be in some other. EcoStruxure is a similar one from Schneider, MindSphere is from Siemens, Predicts is from GE, Lumada is from Hitachi. There's a lot of different systems, and all of them claim that if you put all your data into my system, I can do anything for you. But what we believe is in the future, it will be more how we can cooperate. How we can cooperate with all these. How can they exchange data? How can you get benefit of all your data no matter where it is? That's why we call it intercloud. And that will be really interesting in the future, what will happen here. How do I share my data with somebody? And how do I get some data from somebody that will help me in my business? Okay. This one is kind of how the client could look like for a system in the Ability platform. And then I would like to spend, even if I don't have the time, I would like to spend 2 minutes Anyway, on an intercloud system we created in Denmark as a pilot. So it's what we call the smart energy, and it's first of all it's working with a new technology called LoRa, which stands for long range. And again, it's a lot of devices. So it could be a lot of different devices that you put no matter where in the landscape in the building, doesn't matter. And they typically this size, some are smaller, some are larger, and it has a tiny little battery on it, and it lasts for about 10 years. And it can do temperature measurement, for example, or pressure, vibration. There's a lot of different devices. There's actually push buttons as well for the lighting. And then they have a connection point here, the gateway. And the good thing is that it's very low bandwidth, but the line of sight is 50 kilometers. So with one access point, you can cover a hell of a lot of area. And that's basically what we did in this area. So there's a Danish company that start building up this infrastructure with the connection points. It's called CSNV, so it's over here. So these guys are actually putting out these access point and start selling the devices to customers that want. A device could be some of the what they call digitalized parking lots, where you can see before you go into the city, you can see okay, this parking lot has 7, this one has 8, and actually I can get navigated to the free one because they have sensors in the road and so on. That's using LoRa technology. So in this case, for the smart energy, this one is a district heating for a small little town in Zealand, in Denmark. So there's a district heating up here, and they have a lot of loss in the transmission system because they have to pump out these 75 degrees hot water into the district heating. And they have a lot of loss because they have a lot of pipes here. And there's long distances between the houses here because it's a village, it's not a town. So they was looking for a system how they could optimize this. So we created this application to them that basically take all these different cloud systems and create an intercloud. So from Comstor is what the heat meters that's in the house that actually measure the flow and the temperature. This one is an algorithm that can predict how the temperature and pressure will be in the entire pipe system, putting in some parameters. So it could be due to calculate if they say if we lower the temperature, the floor temperature by 2 degrees, what would happen? Will the family out here get all the hot water they need, or could we save just 1 degree down? And then they can send the request to this one. The algorithm is run on a cloud somewhere, and we'll get result back and present it on the map. And then the last one is OpenStreetMap. It's a way to get the map of everything. So they use this one, and then the SCADA system is basically running the plant, and we interface to that. And none of this is A2B, but this one is. And it's a typical intercloud application. We don't want to push all the data into one place, but we want to get access to all the data. So that's a typical little example. And actually we have it running, if you want to see it in the break. Afterwards we have it running on a tablet. Any questions? Drop me a mail, get connected in the break. Any questions? Otherwise we can have questions afterwards. I'm sorry, it was a little bit speedy perhaps, but this one takes normally an hour.
So, you nearly did it.
I nearly